Okay, I'm back, and we've been talking about weathering, which is the process that takes a rock and then breaks it down into smaller pieces. Now we want to talk about another kind of weathering, which is chemical weathering. Now this type of weathering will change the identity of the minerals that are inside the rock, so it is going to change the identity of the rock. So our first example of chemical weathering is going to be called dissolution. And so what's going to happen here is that water, which is polar, so we've already talked about water, that it has a part of it is negative and part of it is positive. So again, here's our oxygen, here's the hydrogens. This side of the molecule is going to be positive, and then this side of the molecule is going to be negative. Now water is still going to be neutral, but it's polarized. One side of the water is negative, the other side is positive. So if we were to take, for example, NaCl, so NaCl is salt. So it's going to be Na and then Cl. So if you recall from the periodic table of elements, sodium is in column number 1. It's got one valence electron, and it likes to get rid of it. So if it gets rid of a negative electron, that means that sodium, when it's ionized, is going to be positive. Chlorine, on the other hand, is in column 7 of the periodic table. It wants to take an electron, which means that it is going to be negative. Now when you put the two of them together, it's electrically neutral, but it's two ions that are attracted to each other because they have opposite electrical charges. Opposites attract. So what would happen if you've got a crystal made of NaCl, halite, and then you put it into this polar water? Then what's going to happen is that the negative end of the water is going to be attracted to the positive sodiums, and they're going to pull them out of the salt crystal. And similarly, this end of the water molecule, the positive end, will be attracted to the negative chlorines, and they're going to pull them out of the salt crystal. So given enough time, water has the ability to dissolve certain substances. Another example of this is going to be calcite. So calcite is going to be calcium carbonate. And if you look in your periodic table of elements, calcium is going to be in column 2, so it's a +2. And then this part, the carbonate part, is going to be a -2. So that what can happen is that when water gets into calcium carbonate, again, it can pull apart the calcium carbonate into solution, and then these two ions, they get into the groundwater, and then they can be redeposited as calcium carbonate. They can go back together again, and then that's where we're going to get stalactites and stalagmites from. Okay, let's look at another example of this, which this one's a little bit more complicated. So this is called hydrolysis, and again, it's a chemical reaction with water. So this time, if you look up at the top, you see that water and carbon dioxide mix together to make carbonic acid. So that's that H2CO3 thing. So that's going to be an acid. Okay, now that acid is going to mix with the mineral feldspar. Now you don't need to worry about the chemical formula for feldspar, but that's what it looks like there. So the acid is going to react with feldspar, and you can see that it pulls it apart, and then what you're left with is going to be the bicarbonate ions, so that's the HCO3 negatives. You're also going to have silica, quartz, so that's going to be pulled out of the feldspar. And then also you can see a potassium is going to be pulled out of the feldspar. And all of this stuff gets into groundwater. So the bicarbonate, the potassium, that dissolves in the groundwater and can be carried off. Now the quartz, on the other hand, it sticks around, so as sand, and then what's left over has been transformed into clay. So clay is kaolinite, and you can see that it has a different chemical composition than the original feldspar did. So this is an example of a chemical breakdown of one mineral, and then it turns into another mineral. Okay, then you've got another one, and this one is going to be called oxidation. And oxidation is defined when a particular substance loses electrons. For you chemistry people, if something gains electrons, we say it's being reduced. So oxidation is the loss of electrons, reduction is the gain of electrons. Okay, that's not really important. So let's just look at the chemistry of this. We're going to start with the mineral pyroxene, and we're going to mix water with it. And so the water is going to have a chemical reaction with the pyroxene, and what we'll end up with is silica again, basically sand, and you can see that it broke off the iron, so that we have a ferrous iron ion in the water. Okay, now the iron can mix with oxygen in the air or in water, and then it becomes ferric iron, which then transforms the pyroxene into hematite. And you notice that this hematite is the color red because it has been rusted. It has reacted with the oxygen to make rust. So again, that's another example of a chemical reaction. Okay, let's take a break, and when we come back, let's talk about the products of weathering.